Right, hi ladies, this is going to be a quick revision for lesson 23 for the system-wide quiz exam that you'll be taking. Lesson 23 is about alkyl halides and aryl halides, okay? And I'll just be running through the notes very quickly. The first thing that you want to be able to recognize is what's an alkyl halide and what's an aryl halide. So if you see here on this side, we have the alkyl halides, and on this side, we have the aryl halide. Okay. Now, both of them have something in common. They each have a halogen. Halogen is an element from group 17, which is fluorine, chlorine, bromine, iodine. Okay. So the alkyl halide here has bromine and the aryl halide has iodine. The big difference between them is the aryl halide is going to have this benzene ring. This is what makes it an aryl halide if it has a benzene ring. So alkyl halides are just Rx, R being any carbon chain with X. X is a halogen. An aryl halide has a benzene ring. Anything that has a benzene ring is referred to as an aromatic compound. So take a look at these. Here you have some alkyl halides and you have some aryl halides. Now notice the aryl halide has a benzene ring. Do you see that? And this one has a benzene ring. The alkyl halides, they don't have benzene rings, but they have things like fluorine, here's bromine, here's chlorine, here's iodine. Okay, that's what makes them halides. All right, go ahead and pause the video and try to name some of these. All right, I hope you've paused the video and you've taken some time to name your alkyl halides, and now let's just put in the answers here so you can take a look at your work. See if you got everything correct. And you will notice that the aryl halides, they have the word benzene. Benzene is the parent. Okay, so this one is fluorobenzene and this one is bromoiodobenzene. Now we're going to number from the BR. So 1, 2, 3, 4, 5, 6. If you're wondering why we numbered from the BR and not from the I, it's because it's alphabetical order. So because BR is before I in the alphabet, we start with BR. So it's 1 bromo, 3, 5 diiodobenzene. On this side, you have 2 carbons, so it's ethane, and you have a fluorine, so it's fluoroethane. Here you have 1, 2, 3. 3 carbons is propane, and you have a fluorine on carbon number 1 and carbon number 2. So it's 1,2-difluoropropane. And the last one here, you can see how it's numbered, 1, 2, 3, 4. 1 bromo, 3 chloro, 2 fluorobutane. Now notice B, then C, then F. We always write it in alphabetical order. So if you have a BR, we call it bromo. If you have an I, we call it iodo. If you have a Cl, we call it chloro, and if you have an F, we call it fluoro. All right, moving along, the next thing that you have to know is how the alkyl halide affects the boiling point. Now, on the periodic table, you can see that fluorine is first, then chlorine, then bromine, then iodine. Okay, so as you go down the group, fluorine, chlorine, bromine, iodine. Now, if you see here, fluorine is small, and then chlorine is a little bit bigger, bromine is bigger, iodine is even bigger. So as you go down the group, the boiling point will increase. Okay, boiling point will increase. The reason for that is the bigger that it gets, the more electrons it's going to have. And because it has more electrons, it can make stronger temporary dipoles. Or you can say it can make stronger bonds. Okay, because it has more negative, it's going to be stronger. So if I gave you, for example, CH3Br and CH3I, and I asked you which one has the higher boiling point, you would say CH3I. Okay, so as you go down the group, boiling point increases. Here's a question for you. Just pause the video and try to answer. Okay, I hope you've paused the video and you've answered. Now, in the first one here, you have BR, I, and F. Remember, on the periodic table, it's like this: F, Cl, Br, I. So which one is going to have the lowest boiling point? It's F. So we're going to start with F. So this is the first one. Then the next one is going to be Cl or Br, so that's this one. And then the last one we're going to write is I. So this one is going to have the lowest, this one is going to have the highest. Okay, very simple. All right, moving along, you should be able to explain why alkyl halides are used in the chemical industry as starting materials instead of alkanes. Now, if you look here, you can see CH4. CH4 is methane. CH4 is methane. You know that alkanes are completely unreactive. So, if you add a halogen to the alkane, like this, see how we took away one of the H's and we added the Cl in its place, you can make it more reactive. So that's why alkyl halides are used in the chemical industry, because they are more reactive. They are more reactive than the hydrogen atoms they replace. So here you have hydrogen, here you have Cl. Which one is more reactive? Definitely the Cl. All right, the next thing you have to know about is something called CFCs. CFCs are chlorofluorocarbons. Okay, so you can see chlorine, fluorine, and carbon. So here you have a chlorine, and around it you have here you have a carbon, and around it you have chlorines and fluorines. Okay, these are called CFCs. So they are alkyl halides. They contain chlorine and fluorine. Very simple. There are two CFCs you have to know. They are Freon 11 here and Freon 12 here. Now take a look at these two structures. You can see that the Freon 11, it has 3 chlorine atoms. The Freon 12 has 2 chlorine atoms. Okay? The Freon 11 has 1 fluorine, and the Freon 12 has 2 fluorine. Okay, so be prepared in the exam to recognize Freon 11 and Freon 12. You can remember Freon 12 is 2. So you have 2 fluorine and 2 chlorine. Okay, if that helps you a little bit. Now, Freon 11 and Freon 12 are used in things like refrigerators. They are used in ACs. See here the air conditioning. They are used inside the refrigerators, and they are used inside of a spray can to make the spray come out. Okay, they are very dangerous substances because they destroy the ozone. They are danger. Okay, they are very bad substances. They destroy the ozone. So we have something new sorry about that. They have something new, so we don't really use CFCs anymore. They are banned because they are very bad. Now we use something called HFC. HFC is a hydrofluorocarbon. So a CFC would look something like this. ClCl. FF, this is Freon 12 because I have 2 Fs and 2 Cls, but in a HFC, the Cl here and the Cl here, they are removed, and they are actually replaced with hydrogen. Okay, this is what we call an HFC. These are very safe substances, and this is what we use now in ACs and refrigerators. You have to know to explain how the CFCs destroy the ozone. Okay, that's important. So if you have a CFC, how does it destroy the ozone? So you can see here, this is like a little picture of what happens. In the first picture, you can see this is a CFC. Is this Freon 11 or Freon 12? You have 1, 2, 3 chlorines. This is Freon 11. And when the UV light hits the CFC, this is like UV light from the sun, yani. The chlorine atom is going to come off, and the chlorine atom is going to attack ozone. This is ozone, O3. O3 is ozone. The Cl is going to attack ozone, and look, it's going to break it apart. It's going to break apart the ozone. And then a free atom of oxygen will collide with the chlorine, and it will take the oxygen away, and the chlorine is free. So it can go and attack another ozone, and the cycle just keeps going and continuing, and this is how it destroys the ozone layer.